So there's my Twitter handle. I've been working in performance for about 12 years, but I've been in software quality for about 18. Most of this time, I was working alongside developers, and we were putting out a commercial software product, developing it iteratively, sending out major releases a couple times a year. So kind of working right there with the team. A little bit before at least the capital A Agile existed, and definitely before the Scrum bags took over, we were working that way where we were talking about small things, working together, cutting code every day. What's brought me to Malmo is that Maria and Verisher are hosting a workshop for performance testers Wednesday through Friday this week. If you're interested and can get some 3 days off, I'd be happy to talk to you about that as well. But we're a peer workshop in performance testing. So I want to know a little bit more about who you guys are before I go on, and I can kind of tailor it a little bit. Are we all software testers here?
No. Yeah.
So this is the way we do it. Software testers, developers, performance testers. Okay. Well, right. See, there's a lot of that more, so I actually live in Mountain View, California, which is the headquarters of Google, and it's in Silicon Valley. And they're trying to do there is just kind of smudge all of those roles across. And well, we don't need a performance tester anymore. We'll start to just have our quality people do non-functional requirements like reliability and testing. Or we'll push that towards operations and call that a DevOps role. And the calling yourself a performance tester is kind of an old school label, and there aren't a lot of people who do just that anymore. I do that because I'm a consultant, but there aren't a lot of people who get paid by one person to do that all the time. So I don't want to talk about flavors of Agile and Scrum. I'm a little skeptical about many aspects of that, and I definitely am not into debating what's pure Scrum and what isn't. I do think that there's this pattern of developing iteratively has become very common, and this is the way most people that I know still do their work. Now I still talk to people who work for insurance companies who work on a claim system for 4 years, and it has this milestone way out in the future, and they don't develop this way. But this is definitely the state of the art, or at least the state of the current. So as I said, no process tiering here, and I think there's a lot of different ways to apply what I want to talk about to any iterative process. The biggest challenge for performance testing, the way it's been done traditionally, is that Agile rewards immediate feedback. Tell me what's wrong now. Test my feature now and tell me how it works. The old way to do performance testing was, the very bottom of the waterfall, and always the week before go live when you can best make use of some feedback that something's wrong, of course. And it's not very helpful when as you're building things agilely, which is also kind of a way of saying quickly and with the minimum viable product. To come back later and tell me I did it wrong is not so helpful. So what do we do to give you feedback on performance earlier, as opposed to, at the end of the project, once we've got our production hardware, once we've got everything in place, we're going to run one test, and that's going to tell us everything we need to know, and we can go live or not go live. But that's the way performance testing has been done for 20 years. This is as geeky as this gets, I promise. This is a very high-level architecture diagram. We'll get to it later to start talking about specific components of this as we go. This is more of what our roadmap looks like. These are the subjects we're going to cover today. What are the risks we are testing for? When somebody says, I need a performance test, what is it that they're worried about? Well, I've got they're saying, is my system going to work correctly? And traditional performance testing turned this into an experiment where I'm going to make this detailed model. It's going to cover what we think is the most important things to do in our system. And we're going to figure out how many times per day that this happens and how many times per hour that happens. And we're going to write a bunch of scripts, and then we're going to build it all up in this model of what the load is, and we're going to run it on a copy of production hardware, and we're going to get these response time goals. And that was the test for, is the system going to be deployed or not? Well, we live in a continuous deployment world, at least in Silicon Valley. That's kind of how things go. So that breaks down pretty quick. I'll talk a little bit more about this later, but the rest of these don't hold up very well to much analysis either. How do we address these risks earlier in a process? So scalability is the idea our system's not going to scale. It's not going to support however many users are doing however many things that there are. In the United States, we talk about the healthcare.gov problem that happened last fall. So one of the ways that my country is way behind is that we don't give healthcare to everybody. So they have this elaborate system they built for people to purchase health insurance, and then they made it so that there's a tax credit so that you can buy it, and they had this day where everybody would come onto the site and sign up for their new health insurance. Well, the site went down right away. So the political opposition, on the conservative side, have just been beating the guy up for 6 months about this, about how the website just didn't get off the ground and how this website being broken was a metaphor for how the policy was broken. It was very terrible. The other story people use to talk about that is the big advertisement on the American football Super Bowl game every January. That's when the most expensive television advertising happens, because nobody watches any one show more than this one show where something like 60% of the country is watching at this point. So people will save up millions of dollars to buy the one ad, and you'll put in your website in the ad, and then everybody comes to your website and it goes down. So all the money you saved up from your seed funding to buy the ad is flushed down the toilet because what everybody saw is that your website isn't up. And that's the brand impression that was formed. This is what most people are thinking about when they talk about why I need a performance test. Is it scalable? Can I put these people in the system and have it continue to function correctly? Some people approach this as an ops problem. They say I can keep putting more computers on. Well, if I can't do it with 4 servers, I should be able to do it with 8. And if that doesn't do it, well, servers aren't that expensive. I'll just buy 4 more. This becomes I like this. I like little cynical jokes like this. You know, as we've continued to make faster hardware, we've continued to make crappier abstraction layers and frameworks so that our software actually runs slower on hardware that's 100 times faster than what we had 10 years ago. One of the weaknesses of analyzing this kind of problem is that it's meaningless without the other parts of our equation, right? What are users doing on the system, at what frequency, and how are they arriving? It's really hard to say, will my system scale? Well, how many people are going to use it? What are they going to do? You kind of need to understand all of that to be able to answer the question intelligently. What does this look like? Well, anybody can see a longer response time, but our tools also will tell us that. So over time, if the response times increase, that means that your system's under too much load. You could mine a web log to see this if you have response time turned on. This is the first metric most of us look at in a performance test. See how the CPU on that machine is doing to tell if it's doing too much work or not. When a system isn't scalable, or an activity in the software isn't scalable, those are the things that you'll see. So that's kind of like we call that the 7 pounds of computing in a 5-pound bag problem, where if something takes a long time to do, requires a lot of CPU cycles, it doesn't matter how many computers you put into it if the work's still so big that you can't put them in those buckets. Another kind of risk is capacity. Now this is a little different, and that's why I'm kind of trying to pull these apart. Is there scalability, like can I put all my users on a system and then that will work great? Capacity refers more to, is the software architecture sensitive to a lot of users? So these are things like the number of connections available from an app server to a database. If I run out of those kinds of performance problems. And this is more of the kind of problem you'd want to give feedback on, where you haven't built enough into this system to be able to support the 1,000 users you think you'll need, But of course, in your unit testing, it looks great because you're testing one person or you have 3 people logged onto a system. These are the really great performance war stories are these kinds of problems where somebody never engineered it to actually support the number of users they think they were going to support, and nobody discovered it until the load actually arrived. This one comes in sometimes with how big the data set is that you're testing with. That could get pretty geeky. Please.
How is it with the data generation? I think you can also test data generation techniques to reduce the test cycles a lot. Test data generation with this data masking and you have special tools for this. That you can generate, specify the data sets. You only use exactly the data you need, because sometimes you generate a lot of overhead data. Do you have some kind of experience in this kind of testing tools?
So I have done tests where we generated a bunch of data. I prefer to just use production data if I can get it. The problem is even if somebody hands me that production data, when I go to code my script, what do? I pick a handful of things that are meaningful. So it ends up being somewhat artificial. A really well-designed test, maybe I would use the whole range, or I'd figure out what the accesses were like across a wide range of data. The reality is we all have a budget of time and money, and we compromise somewhere, and that's the easiest place to compromise is what I've seen.
I've seen a lot of people that use these synthetic test data.
I do have we have in the United States we have some very strict rules about healthcare data, and sometimes that justifies that kind of effort to generate the synthetic data, false patient names and things like that. In most areas, people don't pay much attention to it until it bites them, and then they get all upset about it, and then everybody forgets about it and goes back to how they did it. I think that this kind of issue is something that everybody's seen, but they might not know it. A concurrency bug, where we collide at the right point, we find a race condition, something breaks, we try it again and it works. Oh well, couldn't reproduce. Happens all the time. Under functional testing, if you see one at all, you're lucky. It's probably a bit like catching a cosmic particle, right? If you look at the right time at the right moment, you might see one, but you don't really understand why you see it that time and you don't see it at any others. Performance testing can find issues like this. When I worked for a vendor, a more common thing was, hey, this happened at this customer site, figure out why. And then it would be run the performance simulation to try to recreate a condition like this. Another risk that people traditionally would performance test for. And there's the real common one is the system reliable? Does it have a memory leak? Well, people say, well, I use Java or I use .NET, so of course I don't have a memory leak. And we all know how truthful that statement is, or if you haven't found out yet, you will. That you're still going to run out of something at some point. You will experience a degradation over time. This kind of thing is really hard to test for. A lot of developers will do some little piece of utility code and they'll run through something 1,000 times and say, look, free memory's the same, everything's great. The smarter ones will look a little deeper. They'll see a little bit more. They can still miss things. So some of the places I've seen, like Salesforce.com, is that something people use around here? It's use it to keep track of all the different sales leads you have open. It's a really big company based in San Francisco. Their group is the performance and reliability group. And then even our workshop, we kind of group those things together. It's the same tools deployed a slightly different way. Right? Less about a realistic simulation of a peak hour and more about, if I throw enough work at this system, will I break it eventually? The memory or object leaks, I've got great stories about working in .NET and the developer in charge saying, well, we're using .NET, so we couldn't be leaking. There's no way that we're running out of these things. And it would break the system pretty well. This is an easy thing to see. and these response times decaying over time, that's something anybody can see. And we'll talk about that later, but you don't need a performance tool to get response times. There's lots of other ways to do it. So there's one leg of performance testing I kicked out. Here's the other one, the realistic one. How do we run some test and we convince a business owner that we created this experiment that's just like production and it worked fine, so you're going to do great. Well, it can't be true. It can't be that much like reality at all. Everything that we decide to test is a model. We're wrong at least a little and probably a lot. It's very dangerous to take an experiment using that model and say, yep, this guarantees that your system is going to perform well. If I apply this model, which looks something like reality, then what I learn will be fine. Well, once you're guessing what activities are going to be run, particularly with new systems. This happens all the time where something new is going in and people have no idea how it's going to be used. I don't know, ask an analyst. I don't know, look at the logs from the old system. And we come up with some piece of bullshit we're going to agree on represents at least the thing we're all buying into. And I think it looks like about 500 users. What do you think? And that's how it goes. Yeah, right. Somebody makes a guess, and sometimes it's the business analyst, and pretty frequently on my projects, I can't get anything. So I'll just put something down on paper, and I'll show it to them. And sometimes it'll be, oh, no, that's not right. But far too often it's, okay, good enough. Your guess is as good as anybody else's. We'll go with that. And you always get rid of some activities. You get rid of the activities in the system that are hard to automate or are believed to be executed infrequently. Or you start out with something that you want to automate, and then it becomes hard to automate, and then you decide it's going to be executed infrequently. So it's some subset of what actually can occur in a system. Real work, if you ever watch a log file, for when people log on, it has some organic curves to it. And this minute 5 users will log on, and this next minute 2 users will log on. And then nobody logs on, and then 5 minutes later 10 users log on. This is what reality looks like. But every load tool involves some steady ramp state. Every model that people come up with involves some idea that it's a graph that's going to look like this or this. When reality is that as our level of usage goes throughout a day, it looks more like this rather than these models right here. We give that away first thing the second we open any load tool that has this as the model it supports delivering a load as. You can do some things to make your load more like this, but it gets to be pretty difficult. And that's really not what people want. They want somebody to say, 500 users were logged onto my system and it worked great. And then that's what they can go tell their boss, so at least their ass is covered if something breaks, and they won't get blamed. We talked a little bit about the data problems. Those data problems become worse because of caching, because of how long a system's been up. There's a lot of reasons why that doesn't work. And here's a big one too. On this day, this is what I saw in the system, and then that becomes Bible, that this is how the system gets used every single day. Well, no, it's not like that. Systems are used differently on Monday than on Friday, at the end of an accounting period than from the beginning. That stuff changes all the time. Our understanding is never all that accurate as to what a system is actually sees on a day-to-day basis. We just come up with some arbitrary collection. We decide that the systems we're testing against, well, this is just like production, so this is a fair test. Well, it isn't. All the computer systems and storage I see these days are shared with other systems who are doing other things. So when I test at 8 o'clock at night, it's not a realistic test anymore because it doesn't have all the background load that's running during the rest of the day. Or I ran a test at 2 o'clock in the afternoon. That was on the day that somebody was loading a data warehouse and put a bunch of extra stress on the SAN system. Or it was the day that they weren't. And then I don't get the same thing out. I hear from Java about every time I boot my computer about what version it is. These things are changing all the time. We used to deal with, back in the early 2000s, or the Audis, I like to say, we used to deal with Microsoft patches one at a time until the dam burst and there got to be so many of them that we just kind of like, oh, well, I guess that's it. I guess we've lost that valley. We're done with that. I see a lot of this in my work, the variable network conditions problem. Okay, so we're going to run the system from these 3 remote offices. Okay, well, what's the connectivity to those offices? Oh, I don't know. Or it's this speed to this office, and it's this speed to this office, and this speed to this office. So lots of tests get run right there in the same network as the system that's going to be used and don't take into account where the users actually are. In the mobile space, if you're familiar with testing mobile, this problem is 100 times worse with the variable bandwidth and latency you can experience depending on where you are and how many other people are logged on. And I mentioned this, but these background activities, I mean, a real living, breathing, deployed software application is in the middle of a whole ecosystem of other applications. And they have different demands all the time. So this is just a lot of me complaining about how this idea that we're going to do one perfect simulation and learn what we need to know about performance from it, it's just not true. It's too hard to do. There are too many variables. So how do we take the things that realism means to a stakeholder and use that in Agile? So I like the idea of more control of the environment by using a single server. If I'm going to deploy it onto 6 servers, okay, let's just use one. Maria. Testing subsets. This is something I came across. Trying to do this. Trying to give somebody performance feedback every day, every week. Calibration test is an important idea. I'm going to run the exact same test that's very small and very controllable against 2 builds and figure out what's different between them. Did I make it slower or faster since yesterday? So these are the techniques I've come up with. First of all, the performance test tools, and in where I come from, commercial load tools still are the boss. Load runner is still the start and end of the world. Modern Silicon Valley says, no, I'll use open source. I'll use JMeter. I'll use Selenium and things like that. I still have a lot of the bigger companies. That's what they want. They want to pay a lot of money for a piece of software so they can call somebody and yell at them if something breaks, and externalize the risk of something being wrong. All of these things do is just multi-thread automation with a little bit of a GUI on the front of it. And it captures response times for doing a specific activity, however many times that's done, and keeps track of them and puts them in a database. This is all things anybody could do with their automation. And then it looks at these resources, and it has some tools for showing you your response times next to your resources. That's probably a little harder to reinvent, but you can still look at resources on a system manually anytime you want. You can still graph them if you have to. What I found to be effective for me in trying to keep up with iterative development was to focus on making my tests repeatable and reliable and able to run again right away. I couldn't run one test a day, could I run 10? And that's how I tried to do it. First thing you got to do with the system is be able to log on. So I found if I had a lot of success with how long does it take to create a session on this piece of software, and just track that over a period of time. That's feedback a developer would really like to have. Day to day, as they start hanging things off their session model, if you can tell them, login jumped in from 2 seconds to 5 seconds yesterday, that's something that they can do something with. When they can think of which of the 3 things they did might have done that, instead of telling them 6 months later when they would have to go through all of it and re-engineer it. I mean, it can be done, and certainly people do it, but to give this feedback rapidly, let me do some simple tests and be able to tell you right away when something goes wrong. And when I find something, oh, that was weird. Maybe I should just run that test again. Maybe I should dig into that and figure out why that happened. But if I can find a problem as soon as it's introduced into the stream, we're all going to be a little better off. The comparable environment, forget it. It costs too much. No one will give it to you anyway. Even if they give it to you, it's still not like production because you still don't have all the other stuff running. There's still going to be a shortcut somewhere where your virtualized machine is running on some different hardware than production's virtualized machine. So forget it. All that really matters is that this is repeatable. Give me one server and let me put it in a corner and nobody touch it so I can run the same thing on it over and over again. Once I have that, I can calibrate. I can tell you running the same operation on your software is this compared to what it was a week ago. Oh, you don't believe me? Okay, I'll put on 1 week ago's build of software, run the same test, and show you. And that's the sort of thing that I would do before I'd escalate problems. Is I'd say, well, am I sure that this is that much slower than it was a month ago? And then if it's a simple enough test, if it's cheap and repeatable enough, you can actually do that. More frequently, these heavily orchestrated deployments, that's not so easy to do. QA is testing this build today, and that's it. And maybe if there's an interesting bug, and the developer's stuck, they might go into a previous build. With a performance problem, it's probably more important to give the developer the right lead into when they made something bad, or less than ideal. So with the load tool, these are some of the kinds of loads that I've done. Forget 500 users and 2,000 stuff. Let's do threads. Let me take 10 threads, put with no delays on them, start them all at once and see how long that takes. Okay, that took 17 seconds. I sort of have an idea of how long that, how much computational power that took to get through that. And by not delaying, I just kind of shoved everything all at once. I forced the computer to dig its way out as best as it could. Most traditional performance tests, because they're focused on the simulation aspect, they space things out at human intervals. Well, we don't have to do that now. We have a different motivation. This one I ran a lot. This one I ran sometimes. I didn't feel like I got a lot of use out of it, except for if these iterations started taking variable amounts of time. That would be kind of weird. This was more of a reliability type issue. If I run it 100 times or 10,000 times or 100,000 times, do I see decay over time? One of the things I did is have a computer over in a corner and just turn on the load and come back in a week. Did the software crash in that week? What happened to the response time over that week? What happened to the resources over that week? The person I talked about who said he could never find a leak, this is how I showed him he was wrong. We would go put his software. What function do you want me to run? Okay, well I'll go turn that on. And then I just left, and I came back a week later and said, hey, remember when we talked about how you couldn't leak and that one function wouldn't leak? Well, this system here has crashed. Do you want to take a look at it? You want a crash dump of this? That ended up being pretty helpful to him. So this is probably the biggest difference in traditional performance testing to the kind of performance testing I'm describing here, is making it cheap and fast. So instead of one test being something that takes weeks to set up and needs 20 people on the line, and we go through once and somebody says, oh, I forgot to set that on the database. Oh, well, the results are invalid. Here's a different approach. Let's keep running them. Run 5 tests, and the 5 tests and average your results, that was basically my reporting mechanism. When I was shoving everything at the system all at once, I would get some variation. So I would run several, and if there were any big outliers, then I would go, oh, that's interesting. Why is that? Maybe run some more. If I didn't get any big outliers, I could still average them, and that's what I would go. To run tests every day, these tests have to be cheap. You can't have 20 people doing just a performance test every day. I don't know, maybe in some systems you can, but if you're a tester and you want to give somebody some performance feedback, you have to figure out how to do this in a few minutes. The test and continuous integration. Is continuous integration a pretty sexy thing here? You get a lot of talk about that? Yeah. Yeah, these are the same people who think you're going to automate all your tests as a part of continuous integration. And do away with testing altogether because we'll just automate everything. Well, I have seen some performance tests run as part of continuous integration. Certainly, it would be very hard to do it if you didn't use very simple tests, just because of the amount of scripting and orchestration that has to happen. Well, continuous integration could also be called continuously broken, continuously being troubleshot, but there are people who are getting performance data out of that. So forget performance tools altogether. Look at the automation that you have. You can still get something. You still get something out of it to get performance feedback with. This simple thing of adding a timer to your automation, I don't know why every automation tool doesn't do this by default. I don't know why every automation developer doesn't do this by default. But we can know how long something took. It's really easy. All the scripting languages have a time function. Why can't we just log how long it takes to do something and put it in a table somewhere and see how our response time changes over time? No performance testing expertise required. No special automation expertise required either. Log it to a text file. This activity on this date every day. Just keep appending it. Remember, automation doesn't replace your senses. It doesn't replace testing. But it does make it easier for you to find a problem. So once you've done this, and you can watch the trends, then eventually you're going to have to go do the thing manually and say, with a stopwatch, and say, yep, it takes that long. I think this would be a little off subject to start complaining about how much automation sucks, but that is the biggest problem, is it doesn't replace. It just makes one person more likely to find a problem. Who needs automation at all? You can get performance feedback just by sitting down with a stopwatch and clicking on things and seeing how long it takes. You can use a program like Camtasia, or there's free stuff that'll do screen caps, run through an activity in your software. You have a record of how long it takes to do something. You can refer to it later. You can compare it moment to moment. You can run some dumb automation to stress a system out and then just do a manual test and see how long things take. If I make the CPU at my web server run at 50%, however I do it, and then I go do this activity, how quick is it? And you can do that just driving your mouse. You still have to do some of the things in terms of managing your configuration and keeping good records and being able to go back to previous results. And a lot of this isn't about technique at all. It's about being sure that on this day, this activity took this long, so that you can intelligently claim that on this day, it's 20% slower. Users perceive that. When a user tells you that, they just say, oh, the system's slower now, and that's the extent to which they know. And then somebody overhears them and says, oh yeah, it sure is slower, this system sucks. And that thing turns into a whole viral effect where suddenly everybody loses confidence in a system because somebody claimed it was slow. This turns it into facts. Somebody with no training on a performance tool or system resources can provide performance feedback. Yet traditionally it's been siloed in a way where it's only those guys over there who have the access and training for that tool who are allowed to tell us anything about performance. Okay, so I'm going to shift gears here for a minute, now that we're not talking about performance testing at all, and talk about how I get somebody to pay attention to my problem. Here's another thing. Here's something that really sucks about traditional performance testing is you run a test, and then a report gets generated, and then you just send that to somebody. Well, it doesn't mean anything. It's 50 pages of single resource graphs, or there's nothing to it. When you're a tester, you tell somebody some information that they can use, and you get them to do something. If you don't do that, you're not contributing. You're not adding anything. Lots of performance testers run tests and they generate a report and they wash their hands of it. Yep, I did a great test. Well, did anything happen based on the results of the test that you did? Did anybody change course or do something they weren't doing? Oh, well, nothing happened? Then you accomplished nothing. A lot of this kind of testing that I'm talking about, where I'm doing it by myself, I'm doing it with development, it's a lot easier if I find a problem for me to sidle up to a developer and say, hey, let me show you this, than when it's the big bang performance test and there's a one of those project manager types there who's going to want to escalate everything right away that they think looks wrong in a performance test. If you're looking at performance feedback and you find a problem, you can get credit for that. You know, you'll piss some people off, but you'll get credit for having justified your efforts by finding a problem and getting somebody to fix it. If you collect feedback and you don't get somebody to do anything, then why'd you bother? I mean, this is a big problem as big industrial software testing encounters the modern world. This is a lot of what's lost. Is there's a great deal of generating of completed test plans, and there's not a lot of focus on what did we do to impact the project or change anything. Okay, so to talk more about communicating, if you want someone to do something with what you found, you have to either convince them or embarrass them into doing something with what you found. Well, how do you do that? You know, the emails work because some people see them, even if they don't reply to them. I found that information radiators, like an intranet page, or a whiteboard like this, and then you just go right up in the corner, % change since last week. And if it's in red and it's got a minus sign, someone will always stop and ask you. And you get to explain to them, well, we did this, we added these changes to login, and now it's this much slower. If you have status reports, that's, your boss theoretically is going to read it at some point or skim it. You have a chance to put a chart in your status report, and maybe something will happen. And then there's we call it the grapevine, the unofficial word, which is more important in the end than the official word for getting something actually done. You have if you work on this sort of stuff, someone's going to ask you sooner or later, or you could just tell somebody something and maybe it'll get around. The important thing is to become a status indicator. Is the project going well? I don't know. How's performance doing? Once you reach that, then you're doing well. To where what your opinion of the software matters, and the things you find get fixed, then you're highly effective. Here's the way that I tracked performance across. This is about a year. This was iterative development. These are the daily builds. This was somebody had added a third digit and nobody figured out what to do with it. And then this was the major version on the left. And of course, I've taken out a whole bunch. But the view that showed on the intranet page that all the people in development, I got my one little square corner of screen real estate on the developer intranet page, and this is what I put in it. And it would have just a handful of results, and then, oh no, it was really bad right here. But it got to the point where people were trained that when they saw the number go up, they would ask me, and if they weren't asking me, well then I'll make it bold and I'll italicize it and make it red and get them to pay attention to it. And what would happen is the developers who really knew what they'd put in the software could actually look down this and go, oh yeah, in 9.5 we added that, but then we hadn't put this yet in 10.0, and this all kind of made sense to them. Even if it was confirmational, even if it just told them something they already knew, they said that led to an increase in trust that I knew what I was doing. So this actual test was the 10 by 10 I was talking about. 10 threads, no sleep times, do something 10 times, record how long it takes till the final thing's complete. And I ran enough tests in this simulation that some of these got to be meaningful. Some of the real smart developers started picking stuff out of these columns when I wasn't even paying attention to them. Generally speaking, I pay attention to, when I run a performance test, I pay attention to the mean and the max and maybe the 90, but not really, because nobody really wants to hear about them either. They want to hear, is it Is it perform well, and does it perform reliably well? One last plug. All these performance tools give you 3 and 4 digits of precision. Screw that. Nobody needs that. That's useless. These are too many digits of precision, but I lost an argument on it. I wanted to just use 1. Performance testing and continuous integration. I see it as a making something already hard to keep running harder, because it's more things that can break. You're generating results that nobody uses. I question the value there. You have to get the code to deploy into your performance testing, the system you're going to performance test on, and it has to be the same system all the time for the results to be meaningful, to compare them to a previous result. I have to get the data to get reset into some state so I can use it, particularly if it's consumable. There's a vendor called Sosta. They do a cloud-based performance tool. They've put a lot of stuff out in the last year with white papers of how they're doing this, and webinars and things like that. So this is the last subject header here is, what do we do when a system isn't complete yet? And that's another characteristic of the Agile development process that breaks traditional performance testing. So I'm building a system from scratch. It's going to be it's going to have some things done after 1 week and some more things done after 2 weeks. Well, what do we do? Well, you could use APIs, and those are going to exist for some of the components that are getting put in. A lot of the software development I have experience with is not open source. So this is typically, you'll buy a toolkit from somebody to fulfill some function in your software, and in addition to code and documentation, they'll have an API documentation intended for developers to use. You could still use it for your automation. And then to make up for things that aren't there, usually you need some sort of stub or autoresponder to substitute for that one web service that isn't in place. If you manage to put one of those together, the devs will be happy to use it as well, or they'll have already made one. And one way or another, they figured out how to fill in the hole in your architecture. I like to see what devs have already written for their test harnesses. You might have a piece of very easily adaptable automation there. They're usually pretty smart about not messing around with the interface, because that's a waste of time. If you can figure out how to use their code, maybe add a little bit of instrumentation, you can get some value out of that. It's usually a good idea to find out what they're doing. Now, there's some developers that are just shitty testers, and they push the code over. And there's some developers where their stuff always seems to work. Talk to those guys maybe. Well, what is it that you do? If they run more than one happy path, then they're already thinking like a tester. Unfortunately, a good portion of the developers I've seen, verifying it worked once under ideal conditions is enough, and then they'll send it out. Maybe this is the most important way to approach it, is to test what's there. Just because you don't have a complete system doesn't mean that there isn't still performance feedback to be gathered. As soon as you can log onto a system, I can start keeping track of log in, log off. And what's the one thing everybody does in a system? So I can start tracking that throughout a process from very early on, as soon as that exists. I don't want to generalize across all the different things that software does. Most of them have some sort of search idea, where I'm looking for something in my software, looking for something somewhere, I put it in somewhere, and I push a button, and I get some results back. That lends itself to some early instrumentation. Whatever the overhead is for all of the searches, that's going to be very useful information to your developers. So I think about them like highways sometimes. I've never taught myself like the formal modeling techniques, the UML and this kind of thing, to figure out what happens, all the paths that the software could take. I can't look at it and say, oh, well, you made this a tab at the top of your browser. I guess that's something most people are going to do, is they're going to load that layout. So maybe I should see how long that takes. Find something meaningful to calibrate on. As something changes over time, an arcane function, well, nobody cares if you calibrate against that. It's not something everybody touches. If I find that your login is slower, though, that affects every user of the system. No one's going to take away login at some later date, and everyone's going to use it. This is an example architecture. It's of what a lot of software systems look like. Not all of them, but a great deal of them. Even at internet scale stuff, a whole lot of it looks like this, at least conceptually. Some of these might break up into multiple layers. eBay has like a data layer and then a couple kinds of data stores underneath it, for example. But almost all of them have this idea that there's some place that interfaces with a client that asks for some business logic to be processed that goes and interacts with the rest of the system to do that. There's an authentication, there's data, there's concurrent processes that have to be run. So this is just an example to talk about how to test when all the components are here or not. Here's a really common place to test is take away the presentation layer, just do the web service request to business logic. This is a lot of automation you'll find will have appeared here organically, even if the developers are writing it, because they're checking their this is where the complicated code is running. And it's frequently where you find your scaling bottleneck. So this is the web services have all these functions dumped into some big bucket of a runtime, and it's all being interpreted on the fly, or it got semi-compiled at boot up and then it has to run. If this presentation layer is still changing, it will break all your traditional automation. It'll break your traditional performance testing. If you build something robust that survives the presentation layer changes, then it's more likely you'll be able to run it instead of, oh, that doesn't work and I don't have time to fix it right now. Oh well, which seems to happen to a lot of automation. Here's another example. And we keep coming back to this same problem with the log in, log off, but authentication is a big deal. So in my former life working for a vendor, this would usually be a third party of some type. Somebody would buy an authentication package, and it was going to be single sign-on for the whole organization. And so maybe the user's first experience with your software is how long it takes to log onto the system. You can finger point single sign-on all you want, but this has to work correctly. The day you license this or build it, you can start testing how that performs. How long does it take to create a session? If I create 10,000 sessions in a row, how many of them fail? How many sessions can I create at any one time? I've done tests like that where with very light automation and the right kind of phasing in of the users, can I create 10,000 sessions on this one computer? Sure I can. What arrival rate can I support? Maybe I can support 10,000 users on this system. Can I support 100 arriving a minute? That arrival rate typically tells you more about what a system is more about what a system can handle than some. Under ideal conditions, this many sessions can be active. The arrival rate is usually what breaks things. It's the expensive activities around logging on, creating a session, putting all of the information that's attached to that session in memory. These tend to be computationally expensive, take a lot of time, and is a real good opportunity to find a problem if somebody's making software slow. Oh, well, I'll just add this little bit to this user state, or I'll implement view state because Microsoft said it was a good idea once, or whatever. This is when you want to catch it. I mentioned a company earlier in my presentation, and I'm not going to say who or which one it was. They had big problems with this one right here, the message bus. So if you're not familiar with this, this is the idea that I can create a message and tag it with certain characteristics and put it in one system. Then all of these different components can pick up the messages that they're interested in and do something with it. It's a way to make your whole system asynchronous. Developers first learn how to build this, talking directly to this synchronously, and then they figured out that breaks before too long, and then they have to learn how to do this. And your message bus can be, on a busy website, can be millions or billions of messages deep. And it ends up kind of being the circulatory system of the entire application. It becomes very important how it performs. Most of the big internet companies I've talked to are doing, they grab some open source thing and then they brought it in-house, and they weren't quite scrupulous about putting their changes back out into the community. But this is how they've implemented their systems, and it looks something like this. So how do developers test that message system? Steal that. Usually it's some fairly trivial Java code or JavaScript code to pop a message on or to take a message off. How long does it take to put a message in? How long does it take to take a message off? How many messages can I put on in a period of time? These are characteristics that will define how this entire system is going to perform, that the developers don't even know. They ran a dumb harness. Can you run a smart harness? Or can you run it with some background or some information, or think about more than one system at a time? Of course you can. That's what testers are for. The idea of creating things at a certain rate, it's kind of the same idea as login. Usually it's not how many I did in an hour, it's how many I did in 1 minute that determines whether the system breaks or not. To handle any kind of surge in demand or point load, you have to know that. And then the rate at which I can pull them off matters too. If I say my data warehouse is going to catch all these messages, I have to make sure it can keep up with how fast I generate them. So every component that consumes something from a message bus has a rate that we care about how fast it can read some data. The last component I'm going to talk about this time is the application server. So the kind of systems that I worked on the most recently are what they call an ERP system, like Oracle eBusiness. It's kind of like SAP. Lots of big companies have them. When they upgrade them, it's a multi-year project. It takes millions of dollars, so they sometimes have some money left over for a consultant, which is where I come in. In these architectures, they have some server over here, and it does things like updates the inventory when somebody puts in a sales order, or it'll roll up their demand statistics for a given week or a given month. So this server is actually hitting other components in the system pretty often, but it's hidden from the user. And what we found is that it can create demands that slow down the rest of the system sometimes, but there are also a few important stakeholders who really care how fast this runs. And you'll get business requirements that will say something like, well, we need to update inventory within 2 minutes of somebody making an order. Well, you have to look at this component to know how to do that. So I can throw a bunch of stuff at it all at once and see how it performs. I can ask it to process the inventory updates for 10 sales orders. There's a lot of ways I can structure a test and learn about how the system's going to perform. One of the ways you can trick these things is scheduled processes. I can throw 100 at it all at once, and will it just continue processing until it's done? What happens if it hits the next interval before it's finished processing? If you've got any kind of prioritizing in your system for always process this before this, then you can find some interesting problems that way. That's all testing you can do as long as this thing is running, even if these things are still under development, even if this stuff isn't in place yet. So what did we learn today? I don't know. Here's what I was hoping to talk about. Hoping I would be able to communicate to you. The phrase realistic gets thrown around an awful lot, and I don't think people understand what that means. I don't think that word means what you think it means. But why do they want it, and why are they asking? Well, they're asking about realism because they're worried about scalability. They're worried about concurrency. And they believe that if you can create an experiment that's close enough to realistic, that you will mitigate their risk in deploying. That if there's some problem, well, of course you'll discover it in your test because it's realistic. Sometimes when I hear realistic, I'd like to redirect somebody into saying, Okay, so what is it that you're really worried about? More frequently, we end up just taking their money and doing realistic. That's what they want, and nothing else will do. But this value in making the test cheap and easily repeatable, particularly if you work alongside a development team, that's huge. Traditional performance testing has been too expensive and too hard to do and involved too many moving parts to be done regularly. This shouldn't even just say performance test, it should say feedback. How do we make performance feedback available quickly, repeatably, constantly, where somebody can do something with it? We talked briefly about how important it is to get somebody to do something with your results, otherwise they're useless. I mean, that's still the case. If no action occurs based on the work that you did, then your work provided no value. When you test what you have and test what's going to be important to the system, even the rest of the system isn't there.